Let's try solving this advanced logarithmic equation together. Now, a couple quick things before we get started on actually solving this problem. If you'd like to download a free copy of this PDF, you can find a link in the description box below, as well as an annotated answer key as well. And if you'd like to try the problem on your own, pause the video now so you can give that a try, and feel free to pause whenever you need to when you need to think a little bit more or try some steps on your own. Let's get started. The equation we have here is log base 2 of the quantity of 2 to the x power minus 4 is equal to x minus 1. First, let's go ahead and write down the equation. Now that we have our equation, it's really important that we know what the base of our logarithm is, and in this case, it's equal to 2. Since the base of the logarithm is equal to 2, we can go ahead and exponentiate both sides using a base of 2. The reason why we wanted to exponentiate both sides with a base of 2 is so that on the left side we can use the inverse property of logs, where we know that if we take a given base and raise it to the log of that same base of some quantity, which in this case is going to be 2 to the x power minus 4, and the left side of this equation will just simplify down to equaling 2 to the x power minus 4, while the right side of this equation is still going to stay as 2 raised to the x minus 1 power. Now let's focus on the right side of the equation for a moment. We want to look at the exponential expression on the right side of the equation and try to remember some of our exponent properties here. We want to try to remember that if we have this 2 to the x minus 1 power, that we could rewrite it as 2 to the x power multiplied by this 2 to the negative 1 power. Recall that if we multiply two powers with the same base, in this case 2, then we just go ahead and add their exponents, so x plus negative 1 is the same thing as x minus 1. Then you gotta remember how negative exponents work, so if we have 2 to the negative first power, that's the same thing as 1/2. So we could go ahead and rewrite this expression as 2 to the x power. We're gonna go ahead and multiply that by 1/2. Simplifying this a bit, we could just go ahead and multiply these two pieces together and write 2 to the x power in the numerator, and then go ahead and write 2 in the denominator. Since this 2 to the x power over 2 is equivalent to this 2 to the x minus 1 power, let's go ahead and substitute it back into our equation. Alright, so now that we've substituted back in this different form of the same expression on the right side, we want to notice that this 2 to the x power appears twice in our equation. Now, since this might be a little bit tricky to use throughout the rest of our equation, let's see if we can make a substitution to make our lives a little bit easier. For the next several steps, let's just go ahead and let the variable u represent the expression of 2 to the x power. So u is going to be a little bit easier for us to use, and we can always switch it back to being 2 to the x power later when it's appropriate. Using this temporary substitution, let's go ahead and write our simplified equation. So we're going to have u minus 4 on the left side of the equation, and that's going to be equal to the expression of u over 2, or u divided by 2 on the right side. Next, let's go ahead and multiply both sides of this equation by 2 so that we can go ahead and clear the fractions out. Multiplying each of these terms by 2, we're going to get 2u minus 8 on the left side of the equation, and that's going to be equal to just u on the right side of the equation. Then subtracting 2u from both sides of the equation, we're going to be left with negative 8 on the left side, and then u take away 2u on the right side is going to equal negative u on the right side. Finally, dividing both sides by negative 1, or multiplying both sides by negative 1, we're going to find out here that u is equal to 8. Now, if u is equal to 8, and u is also equal to 2 to the x power, then we can go ahead and write the equation here that 8 is going to be equal to this 2 to the x power. Notice how our base on the right side is 2, and our base on the left side is 8. Now we can actually rearrange this and write 8 as base 2 as well. So instead of writing 8, we can write 2 to the third power, since 2 cubed is equal to 8, and that's going to equal this 2 to the x power on the right side. In order for this statement to be true, x would have to equal 3. Let's go ahead and check to see if this is true, and if we have an extraneous solution or not. Here's the equation that we started with, and let's go ahead and take our solution of x equaling 3 and substitute it in. So we're going to have log base 2 of this 2 to the third power. Let's go ahead and take that 3 and substitute it in for x. Then let's go ahead and take away 4. And on the right side, that's going to hopefully equal this 3 minus 1. We're just replacing x with 3 here. So let's see if this is true or not. On the left side, let's go ahead and cube this 2. So 2 to the third power is going to equal 8. So we can go ahead and write log base 2 of the quantity of 8 minus 4 on the left side of the equation. And then on the right side, let's just go ahead and subtract 3 minus 1. That's going to equal 2. So let's go ahead and see if we can keep simplifying this a bit. Then let's just subtract 8 minus 4 here. That's going to equal 4. So we're going to have log base 2 of this 4 on the left side of the equation, and let's see if that's equal to 2. And finally, log base 2 of 4 is equal to 2. So we can go ahead and say that 2 does equal 2. So this does indeed check out, and x does equal 3. So there you have a little bit more advanced logarithmic equation where we had to be more creative with some of our exponent rules, as well as also using some u-substitution to make the equation a little bit more user-friendly as we were solving, and then we switched it back to using our original expression of 2 to the x power. So hopefully you found this video helpful. If you did, please consider giving it a thumbs up, and as always, keep up the great work that you're already doing, and I'll see you in the next one.